All right, hello there and welcome. My name is Brad Corlett, and today we are going to be learning how to do this 4-band equalizer right here that I made in geometry nodes with Blender 4.4. So we're going to be going through how to make that using Blender. This is going to be more kind of like a walkthrough rather than a full tutorial. I'm not going to be going through every single thing click by click, but I will show all of the different nodes and I will show the different materials and all of that so that you have all of the components in order to build it. And should I miss anything or should anything be unclear, you can go to this URL here and see the video, or sorry, see the blend file that I used. Also, you can take a look at this. This is credit for the music. The music comes from the Free Music Archive. This is a royalty-free place to get music, and so you can take a look at this. I used a song called You Best Boogie by Ketsa. And so with that, let's take a look at what we have in this blend project. And so again, just to remind everybody, this is using Blender 4.4.0. So the first thing I want to talk about is the materials. So if we take a look here, we really have about 8 primary materials, 9 in total, but 8 that are needed for the equalizer. So when you see me move this keyframe right here, the higher up we go, once our audio signal gets louder, more and more of these will turn on until finally, if we go high enough, we get the peak indicator. And so we have 2 different materials for the green, the inactive and the active LED, and then 2 materials for the yellow and 2 materials for the red. Oh, actually, that would be 6 total now that I think about it. Anyway, so let's take a look at those. So you can see we go over here into our different materials, and we have 2 of the greens, 2 of the reds, and then yellow and yellow, and then plain. This is for the floor that you see right here. So these are our materials, and I will just quickly kind of show these on the screen. Again, this is not a full walkthrough, but you can just take a look at the different values that I've set here. We have emission, because this is the active one, so it's emitting a bit of light. We're modifying our base color and a little bit of a few of these other values here. So that's green active. So then the green inactive, we have this information here. Red active, the inactive for red, yellow active, and then our inactive yellow right there. And then also the plane is pretty much simple here. I don't really think, well, there's a few things that have been changed here for the reflection of the spotlight there. So we can take a look at the set. The set is fairly minimal. We just have a floor here, which is that plane. There's a light and of course a sun. So if we bring those on here, you can see what we have. So the floor looks like this. You can see the statistics over here for the plane. Our light looks like this. Here's the values for the light. And then here's the actual light that we're using. And then we also have a sun. And so you can see these values here. So we also have several different cameras here, and I will show you those. And again, I have the location right up here so you can mimic these cameras here. These are just pretty much default settings. I haven't really manipulated those too much, but the location here will be the important part. So I'll just flip through these really quickly here. We have a corner view, a high angle view. We have a close-up angle view, and then we have this top-down look. So the way that the EQ works is, if you look up here, we have a collection with 4 different objects here. Each of these have the same geometry nodes applied to it. So you can go here, you can see them in the modifiers section here, and then this audio signal is what controls the level for that particular one. And so if we go over and we highlight all of these, you can see we can just set them all to random values here manually, just like this. But what makes this an EQ is that you don't always have the same thing, that these are all independents. And so the way that we do that, the way that we bake these in, so if you're watching this, you've possibly seen some of these music reactive node systems before, but what we have to do is actually bake this 4 different times, once for each bar. We need to bake the audio signals in, but every time we do it, we also need to give the tool a different range of frequencies so that all of these move independently. So if you haven't baked audio in like this before, one thing you want to do is first come into your video editing tab. If you go up here to the video editing tab, and then you want to drag your audio file in here and make sure that it starts exactly on frame 1. So you want to do that so that when you render the video, it'll use that audio. And then what we need to do is flip over to the graph editor tab. And so you can see that this is going to show the graph for the object that we have selected. You can see that we have the left one selected, and that graph will change as we go through all of these. So the graph is showing us this audio signal parameter here. And so I've already baked these, but to just give you an idea of how you want to do it, go to once you have the channel highlighted, you come down here in the graph editor to channel, and then it's sound to samples. It used to be bake audio file, but now it's sound to samples. And so then you need to find your audio file here. So we've got that. And then this is the important part. So we're doing the left one, which is going to be the bass. So I go from frequency 0 to frequency 250 for the bass. And then you can kind of do this however you want. Different EQs will break it down differently. I would then, for the second one, do like maybe 250 to 800 for the second low one. So the low, mid, and then the high mid, maybe something like 800 to 1500. And then for the final one, do 1500 to infinity, which Blender usually puts as 100,000 for infinity. And so each time you change those numbers, make sure you hit sound to sample. I didn't actually bake all these in because I've already done it on here. But there are enough tutorials out there that have done that I think you can find one if my quick walkthrough is not enough for you. This is primarily showing the geometry nodes of how to do a 4-band equalizer, and it's going to kind of be a bit more of thinking like a software developer. I'm a software developer and just an artist in my part-time, and so this geometry node setup is a bit different than what you've seen before. This is what the whole geometry nodes looks like, and remember we have 4 of these, so it's a 4-band equalizer. There's 4 objects in each of these. Each of those objects has this geometry nodes applied to it. So what we're looking at is one EQ bar, and we're going to slide all the way over here. Oops, I lost it. So we will start right over here with the source line. So this is the line for one of those EQs, for each of those EQs. And so you can see we just have a curve line node right here. and then we're creating that. We're creating the start and end points here. The start is just 0, 0, 0, and then this is 0, 0, and then our z-axis is just 1 unit. And so we're going to use these later down the line. So let's jump over here to level bars. So we take that source line, and what we do is a curve to points here. And then we feed our curve to points in to instance on points. The number of points that we have is set by this number of EQ sessions variable here, and we're going to be referencing that later. And so we'll be referencing that in other nodes later. So the instance on points, the instance we're using here is a cube right here, and so it's almost a cube. It's a rectangle. It's not quite a cube. You can see the X side is longer than the Y and the Z, which is why we get these horizontal looking bars. And so then we have this increment per EQ session here. And so that's going to be 4 divided by 1, or 1 divided by 4, so it gives us 0.25. We're going to be using that number later. We'll come back to it. So from level bars, we go to the next big section over here, set material from audio signal. And so this is one of those sections I was talking about where it's kind of a bit more thinking like a programmer. So the for each element here, if you haven't used this, you can see you get a space here, almost like a simulation node space. We are going to use simulation nodes a bit later. So if you're not familiar with a for each node, for each node group, basically what that does is it's going to repeat this same thing for each element in your geometry. So we have a line with 4 points on it, 4 instances on points, and so we're going to repeat this whole group for each of those instances. So we're going to loop through all 4 of those. That's what a for each does. We're going to go through and apply the same thing for each element. And so this whole thing is going to be dynamically setting the material based on 2 things: its position in the line, and then also the value of the audio signal. So its position in the line, meaning if it's on the bottom or the second from the bottom, it needs to be green. And then the third one, yellow, and then the fourth one is where we have our red. But then also it needs to dynamically turn it to the active state if our audio signal is greater than a certain value. So let's see how we do that. So we need to look at this part right here. We have this index switch, which if you haven't used an index switch, it's kind of like an index, but you have more options. A regular switch, if we can bring up a regular switch, all that we have is a true or a false, and then you switch it by clicking that. So a regular switch only lets us go through 2 different choices, but we have a lot more materials than that. So we need a bigger switch. And so we drive our switch based on a number. If you look here, you can see all of these are going 0, 1, 2, 3, 4, all the way to 7. So you can see how these are connected. These first 4. So you can see how these are connected. The first 4 of these materials are green inactive, yellow inactive, red inactive. And then the next 4 are green active, yellow active, red active. And so that corresponds to the order that we see them: green, green, yellow, red. And so it goes green, green, yellow, red, inactive, green, green, yellow, red, active. And so then we have to generate a number based on the other parameters that we were talking about earlier. So let's go through how we set this index switch. So to think about how we switch this, let's take a look again at this view right here, paying attention to the audio signal value that I have here in the corner. So right now, all of the LEDs are off because our audio signal is at 0 even. But then once I add any signal to it, even 0.001, that very first one turns on. And then once we get over 0.25, then we get another one. And then add another 0.25, and then we get that one. And then once we get over 0.75, now we're all the way in that last bar, right? So we've divided 0 to 1 into 4 quarters. And then once we get all the way up to 0.99, we get a peak indicator, but we'll come back to that later. So the important part here is to know that we get these bars to light up based on dividing this into these 4 pieces, right? And so then that's why we had this increment per EQ section from earlier. So this, we have 4 EQ sections, and so we want to divide that by, we want to divide 1 by 4, so we get that 0.25. And so that is going to help us figure out this interval. What we do is, remember, we're looping over each of these bars from the bottom one to the top one. And so every time we go over this for each, we have an index for the number of the number that it is in the stack, starting at 0. So the first time we go through this, we're looking at 0 times that 0.25 value, right? 0 times this EQ increment per section. And so that's going to be 0. 0 times 0.25 is 0. So if our audio signal is greater than that, see that right here. So if this index times that is greater than our audio signal, or if our audio signal is greater than that multiplication, then we're going to be turning this one on. And so the very first time that you go through it, it's going to be 0 times 0.25, are we greater than that number? Or for the next one, are we greater than 1 times 0.25, 2 times 0.25, or 3 times 0.25? So the very first element index is 0. And so if that bottom bar is inactive, then this index switch is going to be 0. And so the bottom part of the EQ will be green inactive material. The second one from the bottom, green inactive. So then our index will be 1 when we're looking at the second bar. And so then the second one will get this if it's inactive. The third one is actually number 2, so it'll get yellow. And then the fourth one will get red inactive. But then if those comparisons are greater, if the audio signal is greater than the threshold for that bar, then what we do is we have a little trick where we add the number 4 to it. So then if the bottom bar is active, the index is going to be 0, and then we're going to add the number 4 to it. That's what this does here. So if we are greater than if the audio signal is greater than the threshold, then this switch value will be 4. Otherwise, it will be 0. And so this will add either 0 or 4. If it's less than, if the audio signal does not meet the threshold, then it adds 0 to this number, and then we get one of our inactives. If it is greater, then this will add 4 instead of 0, and then that'll push us down to here. So the first element in this for each loop will either be green inactive when we add 0 or green active when we add 4. So 0 to 4. And then we loop through this the second time, index will be 1, and then it'll be either this one or this one if we add 4. And then the next time we loop through it, it'll be either 2 or plus 4 equals 6. And then the same, it continues with the red. So that's how that works right there. So it may be a bit confusing. Again, it's kind of thinking like a programmer. So if you're used to writing anything like Python or C or Go, if you're a programmer, this will probably make a bit more sense to you. But otherwise, this is how it works. And then the last thing we do after the index switch is, of course, set the material, and then we put it into the geometry on the outgoing for each element node. And so the last part that we want to do here in our geometry nodes is this peak indicator. So the peak indicator shows up when we are over 0.99 audio signal. But then the other thing is that it lasts for longer than the signal is actually over 0.9. So if you look at any meters on an actual EQ or VU meter or something like that, oftentimes those peak indicators will just tell you that it has recently peaked, so in the last half second or the last second or whatever it is. So we're going to be using simulation nodes to determine if it has peaked in the last several frames, and then if it has, then turn it on, or if it is currently over 0.99 for this current frame. So let's go over how to do that. So all of these down here, this section right here, these are all going to be a part of the peak indicator. So we have a few different sections here. The actual peak indicator over here, this is just the geometry of that sphere. Is the peak light active this frame? These nodes calculate that. When was the last frame that has peaked? This will calculate that. And then this right here is the lifespan. So this will determine whether or not it is on. This has our simulation node. So let's start with the basic geometry over here. So I'll zoom in on that for you, and you can see it's fairly basic. So we've got an icosphere here, which leads into a transform. So this transform, you can see, is connected back in here to our original source line. So the top of that, the end point, is what we're connected into. And so the endpoint is just X, Y, and Z. So you can see the Z is 1. So that's our top, that's the upper point in the line. And so what we do is we feed that into here so that we are translating our icosphere up to the top point of that line. Then we have another one here where we add another 0.5 to that line so that we're actually above that last bar. And then we add our red active material to it. So that's the raw geometry for our peak indicator. Moving over to the peak indicator lifespan. So we have our simulation nodes here. So over here we have our delete geometry node, and that is driven by this right over here. So if our peak light active, a name attribute is kind of like a variable. If peak light active is false, then our delete geometry will delete everything. So this switch and the named attribute here are what drives this delete geometry. If peak light is not active, then we will delete all of the geometry for the peak light. So that's all of this geometry over here. And then we set that peak light active every frame of our simulation using this node right here. This one is where we reference the peak light active, but here is where we set the peak light active. And so we're setting it on the geometry. If you don't know, these stored named attributes are actually stored on the geometry. That's why we pass the geometry through it. But then this value right here is what we use to set that stored name attribute. And so is peak light active this frame? So the way that we do that is if the last peak is greater than or equal to current frame minus 10, then we want our peak light to be active. And so we do that by referencing our scene time. We have our frame coming out of scene time, and then we subtract 10 from that. So we want our peak light to be active for 10 seconds. If it only peaks for one frame, or sorry, not 10 seconds, 10 frames. If it only peaks for one frame, then we'll still end up having it lit for 10 full frames. And so then if frame minus 10 is greater than last peak, then we will peak light active will be true. The other important value then is when was the last frame that peaked. So here is how we're setting that. So this stored named attribute is setting our last peak variable. Again, we're storing it on that same geometry. We pass the geometry through that so that the variable can stay with it. And then we set that each loop of the simulation. If our audio signal is greater than 0.99, then that will make this switch true. And so then it will pass through the current frame value. So if this is true, then it's setting the current frame value to the last peak. Otherwise, if the audio signal is not greater than 0.99, then we're going to be setting the current value of the last peak variable. You can see right here, we take the last peak variable and then we set there. And so that's how we kind of keep a running total of the last frame where we had a peak value. And so these two variables get set every loop of this simulation. And so that's how we use those two. So basically, if the signal is currently peaking this frame or has peaked in the last 10 frames, then we want that geometry to exist. Otherwise, we will delete that geometry right here. And so I can show a little bit about how that works right here. So we have one of our nodes selected here, and then I've pulled up the spreadsheet here. So we can look down here as I advance the frame in the animation. We can, once we get to 45, we have that peak light is active. But see how I just moved it to 48? But it still says our last peak was 45, and our peak light is still going to be active until we get to, see, we're at 51, 52, 53, 54, 55. And then once we get to 56, our variable disappears because we've deleted that geometry. And so that kind of shows you how it lasts for 10 frames right there. And so then we can see this here, we're on frame 404, and then we move to 405, and you can see our last peak is 405, peak light is active, and then we keep inching forward frame by frame. And then we had another peak on 412. So we didn't get to the point, we did not get 11 frames past. We had another peak before it expired, and so you can see that that last peak variable changes. And then it changed again on 418, 429, 436, and then eventually it goes away on 446. So that's how it can update and how it manages its state. Thank you for making it to the end of the video. I hope you learned something with this. I hope you liked this, and so subscribe if you want more of this. I'm also a Python developer, and so I'm working on some other coding projects, and so I will be using this in an app, in a music player app. So stay tuned if you like this. Stay tuned if you want more of this. Thank you very much. Once again, my name is Brad Corlett. Have a good one.